chemistry of acid chloride. Okay, so it's mean this subtopic focus on acid chloride. Okay, here are some of synthesis of acid chloride and also reaction of acid chloride. Okay, for the synthesis of acid chloride, it means we want to prepare or we want to produce acid chloride. Okay, carboxylic acid. Okay, carboxylic acid react with any of this reagent to form acyl chloride, and side product depends on the reagent. Okay, so this one slide for the synthesis of acid chloride. We want to produce acid chloride from carboxylic acid using PCl5, SOCl2 and PCl3. Okay, so here are example the preparation of acid chloride from the carboxylic acid. It's depend on the reagent. So there are three types of reagent. So there are three types different of side product, but the main product is acid chloride or acyl chloride. So this one is mechanism thionyl chloride. Please star. Okay, for this mechanism. Okay, the main basic for mechanism using nucleophilic acid substitution. Okay, nucleophilic substitution is mean there are two steps. First, nucleophile attack on C double bond O. Okay, form intermediate. From intermediate, okay, give source of proton to give the stable product. Okay, so here carboxylic acid, and we using the reagent of thionyl chloride. Okay, sorry for this one, OH is a very good leaving group. So for this mechanism, OH attack to this one. Okay, so because of synthesis, okay, OH attack to this one as, okay, pi bond cleave. Okay, once pi bond cleave, so so this nucleophile will attach on C. Okay, attach on C. Okay, so base will abstract this proton. Okay, so electron move to the O, so it become O, and then S double bond O Cl, so HCl as a side product. Okay, so once again, so carboxylic acid, okay, carboxylic acid contain of strong nucleophilic OH. Okay, OH attack on the reagent thionyl chloride as, so nucleophile attack this because this one is more electrophilic. Okay, not this one. This is a carboxylic acid. Okay, carboxylic acid, and OH compared to thionyl chloride, OH is strong nucleophilic. So that's why this nucleophilic attack this one as, so pi bond cleave. Okay, form intermediate. Okay, so attach. So this one O is more electrophilic. So base again abstract this proton. Okay, so electron move to the O, so O there are no charge positive, and then this one O minus akan move to the this one and give the leaving group HCl. So here is here's the first step for the mechanism, and then look at this one, Cl minus. Okay, Cl minus from HCl is a strong nucleophile attack with this one C double bond O. So this one we call it as the nucleophilic substitution. Okay, Cl, so C attached on C carbon. Okay, this one it become cleave, pi bond cleave, and O minus. Okay, so this one is intermediate. Once O minus, okay, move to this single bond, and then move to this one and move the Cl. So this is the end product of the mechanism thionyl chloride reaction. Okay, before the carbonyl become more electrophilic, so the thionyl chloride must undergo this one step, and then once you get the chlorosulfide followed by the nucleophilic substitution. Okay, so look at for the reaction. Okay, first hydrolysis. So hydrolysis means that we want to convert acid halide into carboxylic acid. Okay, first reaction we call hydrolysis, acid chloride. Okay, we're using acid chloride and then react with the water to form carboxylic acid. Okay, side product is HCl. Okay, this one is mechanism for hydrolysis. Okay, so this one react with water to form the carboxylic acid. This is just general equation for hydrolysis. But look at the mechanism. Step 1, water. Water, there are 2 lone pair. So this lone pair attack on this carbonyl because this carbonyl is more electrophilic. So because of more electrophilic, so this nucleophile will attack on C double bond O. So it cause a pi bond cleave. Okay, pi bond cleave. So produce alkoxide side product, which is intermediate form. Okay, so this one OH attached on C, so O become positive. Okay, so O minus. So please focus on this structure. O become positive, and this one carbonyl O is minus. Okay, step 2, eliminate step occurs when pi bond. Okay, pi bond forms between C and O. Eliminates step occurs when this one O minus, okay, form pi bond between C and O, and the ion chloride will remove. Okay, so this one Cl minus and this one become product. Okay. Okay, so product. This one is not product. This one is intermediate. Okay, because of this intermediate is not stable. Because of O is still positive charge. We don't want this positive charge. So continue with step 3. Ion. Okay, proton ion is removed by chloride ion to yield HCl. Okay, how to remove this proton by adding of chloride ion. Okay, chloride ion is very strong nucleophile. Okay, abstract this proton. Okay, so the electron move to the O, so it become carboxylic acid and side product. So there are 3 steps for the hydrolysis. Okay, by using the nucleophilic acyl substitution. Okay, so next is alcoholysis. Means that alcoholysis, acid halide react with any kind of alcohol by using the pyridine as a reagent to form carboxylic acid. So reaction is better with the less steric bulky group. Okay, if less steric bulky group, so this reaction is much better compared to the bulky group. Okay, acid chloride react with phenol to produce ester. The reaction is not vigorous. So there are 2 types. Okay, first if aliphatic, number 2 if react with phenol. It means the alcohol, there are 2 types, aliphatic or inaromatic. Okay, so acid chloride react with phenol using pyridine. So the product produced is ester. Okay, derivative of carboxylic ester. So here is the mechanism alcoholysis of acid chloride. Okay, so this is a general equation. Step 1 same like from the previous. Ethanol. Okay, ethanol will attack the carbonyl, so pi bond cleave, so it become O minus. So this one will attach on C after the nucleophilic attack. So they attach here. Okay, it's attached here, so O is become positive. Okay, now it's O. O, there are 2 lone pair. After attack, so it become 1 lone pair and charge positive. While for O, it's become lone pair. Sorry, become negative charge. There are 3 lone pair attached on C. So here is step 1. nucleophilic attack on C, so O become positive, and pi bond cleave, so O become minus. Step 2, double bond of carbon-carbon regenerate and push chloride ion out of the molecule. Okay, so step 2 must be have a word of regenerate. Okay, so how? Because of intermediate minus, will move electron to here to form elimination. Elimination means that form pi bond between C, O. So this one turun, form pi bond, and then leave the Cl leave from this carbon, but this one is remain. Okay, step 3. Okay, proton ion from this one will remove by chloride ion. So chloride ion abstract this proton because we don't want this O in positive charge. So that's why chloride ion abstract this proton, and then electron move to the O, so O become positive. Okay, and product, and this one HCl side product. Okay, so this one is ester. C double bond O, OR, you get the ester. Okay, so means by alcoholysis, acid halide react with alcohol to form ester. So next, aminolysis. Okay, for aminolysis, acid chloride react with ammonia to form primary amide. So this acid chloride react with primary amide to form secondary amide. And last one, this acid chloride react secondary amide to form tertiary amide. So from amino acid, we want to produce primary amide, secondary amide, and tertiary amide. It depend on the reagent we are using. Is it ammonia, or primary amide, or secondary amide? So the types of product, it depends on the classification of amide. Okay, this one is the example. So the mechanism for aminolysis of acid chloride. Okay, this is general equation. Actually, the mechanism mostly same for all the reaction. So step 1, ammonia attack to the carbonyl, because ammonia is the strong of the nucleophile. So nucleophile will attack on C double bond O, because of C double bond O is more electrophilic. So ammonia attack on the carbonyl, carbon will cause the pi bond cleave. Okay, ammonia lone pair on the ammonia attack on C double bond O, C positive, so remain on the C, and then this one pi bond cleave to form O minus. So this product we call as intermediate because of the formation of O minus and also formation of N positive. Step 2, we want to eliminate. Eliminate means that we want to form pi bond between CO, because of O is minus. So this one lone pair move to this one, and it form a pi bond between CO. Okay, but this one is still remain, so Cl will detach from the C center, C carbon atom center. So separate is Cl minus. Step 3, we want to remove ion proton by chloride ion to yield HCl. This one Cl minus. Okay, abstract proton, so become HCl. Okay, so this one electron move to the N, so charge positive will disappear and become the amide product. And this one is ion chloride, but also same process can be happen by ammonia molecule, because ammonia molecule have lone pair. So this lone pair abstract this proton, so to form ammonium ion, and this one become amide product. So there are two situations. Either you want to use a chloride ion to remove the proton, or using ammonia molecule to remove the ion proton, but the end product are same, but the side product is depend on the ion that I use in this step 3. So next is reduction of acid chloride. Okay, first, acid chloride are reduced by mild reducing agent to form aldehyde. Okay, there are two types of mild reducing agent. Reduce of acid chloride, you want reduce acid chloride to form aldehyde by using this reagent. Number 2 is strong reducing agent, so form alcohol, primary alcohol. For this one, mild reducing agent, so end product is aldehyde. If you are using the strong reducing agent, so the product you get the primary alcohol. Okay, this one is alcohol by using this strong reducing agent. There are a lot of the reducing agent, so the strongest reducing agent is lithium aluminum hydride. So next is reaction of acid chloride with organometallic reagent. So we know that organometallic reagent is Grignard reagent, react with acid chloride to form tertiary alcohol. Okay, by using the Grignard reagent in ether solvent and source of proton, so it will give the tertiary alcohol. So next is conversion to acid anhydride. From the carboxylate react with the acid chloride to form acid anhydride, sodium carboxylate. In this case, we using the sodium carboxylate, not carboxylic acid, and then react with the acid chloride to form acid anhydride. This is a general formula for acid anhydride, acyl or acyl, and side product is sodium chloride. Next is Friedel-Craft acylation. This one is Friedel-Craft acylation. So this one, benzene react with the RC double bond OCl, is mean acylation. We use the acyl halide. Okay, reagent aluminium chloride, so form product ketone. So here is some of example. The product is ketone, C double bond O R R, R C double bond O R. So next is formation of ketones from acid chloride. Okay, produce ketone from acid chloride. Okay, this one acid chloride react with lithium diorganocopper, or we call it as Gilman reagent. So produce acyl diorganocopper intermediate, and followed by the formation of ketone. End product ketone. Before this product obtained, so the intermediate is acyl diorganocopper. Next, acylation of enamine. Okay, this one enamine react with acyl halide. Acyl halide to form beta dicarbonyl. Okay, acylation, acyl, we using acyl halide with amine, okay, to form beta dicarbonyl product. So next, acylation of enamine. Okay, first we want to acylation enamine. So here is the mechanism acylation of enamine. We want to form enamine first. So this one amine react with this one ketone and to form enamine. This one is enamine. Number 2, nucleophilic attack. Okay, nucleophilic attack, it means this double bond is more nucleophile. So nucleophile attack with this C double bond O to form iminium salt. Okay, and then leaving group removal, leaving group. So it means that after attack, so this one enamine will attach on C C. So O pi bond cleave to form O minus. Okay, this one is become positive. So leaving group, so negative lone pair move to the sigma bond to form pi bond, double bond elimination, eliminate to form pi bond, and then X will become a leaving group. Okay, become leaving group. Number 4, reform the carbonyl by hydrolysis. Okay, once you get here, we don't want N in condition positive. So what happened? Again, so X minus, okay, X minus using HCl water, so reform the carbonyl by hydrolysis.